Hello, Twitchies. Hello, Bruce Wayne 22. I did the math for you. Wait, why didn't this open in preview? Why did that open in Chrome? Here it is in preview. Does it really? They didn't put any index? Okay. They know, they know, they know. Is that a Drake lyric? They know, they know, they know. The real is on the rise. Fuck the other side. I even gave them a chance to decide. I just tell them they know. No, Cherry Computer's not canceled. No, no, no. Look, guys. If starting your company is not a struggle, then you didn't think about it enough. When I started Comma, I was smoking weed every day. Real facts. So, yeah, we got a few things to do today. I've been working on. We can do the website. Do you guys want to do the website for Cherry Computer? I was just thinking it would be that logo that some guy linked yesterday. No, what's this? Oh, floating points. No. I was just thinking it would be that logo and then a picture of an NVIDIA graphics card, and it would say, "Don't you wish you had a choice?" Should we put the website together just because we're here having a good time? All right, well, you know, someone probably copyrighted this cherry. Did anyone copyright this cherry? Nah, I can't be copyrighted. It's illegal to copyright a cherry. Image source cherry.svg. We want everything, of course, to be in the center. You guys know this is my HTML code. What's that? It's a thesaurus line. Thesaurus rap battle HTML code. No, yeah. Oh. Yo, here's the difference between you and me. I do shows and get lots of head. You do shows with ostrich head. Yo, I do tours, get paid, and stay at the Sheraton. You give tours at the Monterey Bay Aquarium. Yeah. So let this skinny dork go back to making shitty Mongolians. If you ain't nailing a railroad, you're playing yourself, bro. And I don't mean he's afraid when I say that he's yellow. Here's an antenna, taping some Velcro. Gonna make me a cell phone, then do my fucking HTML code. All right. So, you know, we're just going to put it big. Yeah, center tag better work. Don't you wish... Oh, no. It's got to be a picture. Wish you had a choice. Let's get a picture. Let's get a picture of an NVIDIA. Whoa, CSS. Whoa, who needs CSS? Whoa, the wheel's on the rise. Fuck them other side. You know? No. Let's get a picture of an A100. Oh, that's not a good picture. That's a good picture. Yeah, I'm stealing this picture from my website. All right. I did hear that you could buy pictures of these cards on eBay, and they were selling for a lot of money. Just picture. All right. Let's rename that to 3090.jpg. Image source 3090.jpg. Let's terminate my image tags. Do I know HTML? We're not closing any other tags because fuck closing tags. All right. No. We need some burrs in here. Yo, where's Icy Narco? Yo, we need some burrs. Burr. We need more burrs. All right, we need more burrs. All right. Don't you wish you had a choice? Now let's just put a lot of burrs here. Sherry. Coming 2022. We need some burrs over here. Burr. All right. Oh, it's got to be big. Everything's got to be big. I don't know why you'd ever want your text to not be big. We need more bigs. Don't you wish you had... Oh, but now the burrs get bigger. That's a little much. All right. Cherry. Computer. We need another burr here. All right. Good thing we hired a graphic designer. Wait. Let's just copy this amount of burrs down here. Oh, yes. Beautiful. You guys like my website? Oh, you can't see. I'm in the way. I'll put it over here so you guys can see. All right. It's a picture of an NVIDIA graphics card, and it says, don't you wish you had a choice? And then it's Cherry Computer 2022. For you want job? Only GitHub. And we'll put that in a comment, so you have to be Lee to find it. Perfect. You know what it used to say on the comma website? Till everyone who doubted me is asking for forgiveness. If you ain't been a part of it, at least you got to witness, bitches. And that's how I feel. That's how I feel, Waymo. That's how I feel, Cruz, you know. That's all. Everyone believes it. Everyone believes it. Sorry, Drake. I stole your bars. Drake used to be good, guys. Drake used to be good. Cherry's just the name of the computer, you know? We'll put it, it'll be a good logo on the chip. Don't you wish you had a choice? Cherry Computer. Oh, you know what? I won't say coming 22. Winning ML Perf in 2022. What do you think? Per watt in 2022. No, I don't think we can win per watt. We'll just say showing up. Winning is a little much. Winning 2022 on ML Perf. Winning ML Perf. No. Just yeah. Cherry Computer. Custom card you can buy. ML Perf 2022. Find us on ML Perf 2022. No, we'll just be on ML Perf. And maybe we should link to that. I linked to it already, so I'll show you guys. I have a business model. I've been working on this. So this is like the plan. Here we go. Let's say by the end of the year. We'll be on MLPerf. Oh, we need late to be all capitalized. I forgot. Cherry Computer is an all capital company. All right. Don't you wish you had a choice? No, and we gotta keep it with the, you know, don't you wish you had a choice? Yeah, perfect. Cherry Computer, custom card you can buy. Yo, this is a good website. Hang on, let me move my face so you guys can really see my website. I worked hard on this website, boys. Don't you wish you had a choice? Cherry Computer, custom card you can buy. Where's the buy it now button? Should we take pre-orders, but they're only $1? Like Cybertruck? Pre-orders, but they're only in cheap ETH. No, let me tell you guys why I'm done with cheap ETH. Crypto is a cesspool. Crypto's a cesspool. You know, I was at lunch today, and what we're just kind of saying is like, who's creating value in the world? You know what I mean? You know something is a security when you're trying to make value off the air. Well, let's look it up. Let's look up the Howey test. You know, for all you guys out there trying to make shit coins and like you learn about the Howey test, right? And it's like, yes. An investment contract exists if there is an investment of money in a common enterprise with a reasonable expectation of profits to be derived from the efforts of others. Now, what you can find is that if everybody in the world is just trying to make profits derived off the efforts of others, but nobody's actually doing any effort, then everything's fake. Like imagine instead of the stock market being backed by companies, because well, they're really even companies anymore, they're all just financial instruments, right? So it's like you're just betting on all these different shit coins, then you realize we already have this and it's crypto, right? Like, yeah. So yeah, if you're interested in working at Cherry Computer, you contribute on GitHub. Yeah. All right. I think this is a great website. Well, no, it's just everybody today. Everybody today is like, oh, I'm just going to make money passively by investing off the backs of others. But if no one's doing any real work, like nobody has jobs. You know, you like go out and there's just people everywhere because nobody has fucking jobs anymore because you gave them free money and you can't do that. So like, welcome to the decline. Yo, guys, I was on 4chan last night and I read this post and it was just like, bros, you know, like all that like accelerationism where you think like there's going to be like a big event, there's going to be like a big recession. Nah, it's not going to be like that. There's just going to be slow and steady decline for the next 20 years. And that's what I'm really scared of. And then the third post now is like, bro, yeah, read a history textbook. That's what it looks like when you live in declining empires. Like, it's not cool. It just sucks. And it just sucks slightly more every year. And I'm like, holy shit, that's what we're living through. Yeah. Oh my God. Yeah, UBI. Yeah, let's all make money. What if we all made money off of everybody else's work, right? This is all this. Every time you hear words like collaboration, it's just all this bullshit. It's people just trying to make money off the backs of others. And that's great if you have a small defector class that scams everybody like that. But if your whole economy is based on these kind of scams, well, what's left? Do you know what I mean? Don't you know? No, I mean, we just need to legalize, like, heroin and shit. And, like, all the people who want to, like, go do heroin can go do heroin. And, like, You know, all the people who want to wirehead themselves, let them wirehead themselves. Don't give them UBI. Give them a morphine drip. You know, we can synthesize morphine in huge quantities. Is this did Matthew McConaughey say this in Wolf of Wall Street? Let's watch this clip. This isn't copyright infringement because we're only watching a short clip. No. You'll literally send the GME people to the moon. Yeah. No, I mean, like. Yeah, the Fugazi scene. Yeah. I saw Fugazi. Look, the GME people. I'll blame the GME people, but like, does anybody think the price of GME has anything to do with GameStop? Oh yes, remember when GameStop launched that great new thing, but then it turned out to not be great. But then oh wait, no, GameStop didn't do shit. This is all just speculators. Right? And then like all these people are like, oh yes, oh buy a crash, oh yes, Market Watch, yes, Vox, please, oh yes, the Motley Fool, let me guess, it's GameStop. Right? Like I hate all these people, man. And it's not the guy who like memes GameStop who I hate. Right? It's anybody who takes the system seriously. Recursive speculation. It's not a short squeeze anymore. It stopped being a short squeeze. Like Wall Street's making money on GameStop too. You know who loses money? Everyone who says diamond hands, diamond hands, diamond hands. Like you're gonna lose. It's a question of when. Like the market will eventually. Look, I don't want to talk about this. I'm just saying that, you know, we're going to create a new society where people who want to create value just for the sake of creating value, I decide that I'm going to create value because it pleases God. And like, it's that simple. And you can't really have like another explanation for it, right? Like, it's like, there's no reason to create value today. I can make bajillions of dollars scamming people. Not bajillions, but you know, I could have a solid, you know, like $50 million just off scams, maybe even more. I don't work the system. Fuck the system, man. All right, you know what? We're gonna read comments and then we're gonna get into today's stream. I saw a comment. I saw it was a good comment. I liked it. All right. Hotz is depressingly cool. Yeah. Anyone who types louder than me. No. George is the example of how you can act if you're successful and you do moral, honest work. You know what's going to fix this, guys? Shaming. When somebody like makes money off the backs of others, you should shame them. When somebody like collects unemployment, you should shame them, right? Like this is the only way we're gonna fix this. You know, what's that? This is Tupac, man. Tupac had. Yeah, you gotta operate the easy way. I made a G today, but you made it in a sleazy way. Yeah. No, not social credit. Like this thing, you can't do this top down. You gotta do this bottom up. Like every one of you, we got 420 people out there. Yo, 420, blaze it. You gotta just like, you know, like that's not cool, bro. Like we all just gotta turn to people. Like, you know, unlike what everyone's like being shamed for, like, you know, publicly on Twitter, like fuck all that noise. I mean, like go to people personally and be like, yo, like you're a loser. I've done this to people, you know, like this is just, you know, you're a loser, man. Like, yeah, okay, yeah, make money off the backs of others. Who do you think built society, you know? No, and like I do this to these people. Like I meet these people who, you know, create no value. They just take value from the system and like just, you know, bro, like you're a loser. But no, we're doing ML perf. talking about like the people buying and selling scams. I'm really just talking about the whole. I want you to, wouldn't you feel better making as much money as you can so you can do good things with it? No. Money is worthless. Money is backed by human effort. If there's nobody putting in any effort, money can't buy you anything. Why is the inflation so crazy? It's not because of the money they printed. It's because you have people now who think it's an okay lifestyle to not work. And like, no, you're a piece of shit, right? And like, this is what we need to bring back. Do I think everybody has a moral obligation to contribute to society? I mean, depends what you mean by society. Yes, I think everybody has a moral obligation to be a positive force in the world, of course. Yeah, Elon has more tolerance for this than I do. It's hard for me to tolerate. No, I think Elon creates immense value. Yeah, I mean, that's what, exactly. Elon lowers the cost of many systems, right? Like, think of the Boring Company. It's just like that's what we need more of in the world. It's like, we're going to take this thing that we can do and we're going to make it 10x cheaper. That's what makes the world better. No, it's not about incentives. And this is how we're going to move past, like, this fake capitalism shit. Like you just got to look at people and, it's kind of like what people say about, like, the billionaires. Like, do you really need more money? Well, yeah, people who put effort into worthless ventures, like, I say this stuff a lot on my stream, but this is really like a call to action. If you work at a job where you know that you create no value, quit. Quit, or you're a total loser, right? Like, I'm sure some of you out there have jobs, and you know that you do nothing. You know you contribute no value to the world. You might even take value from the world. Quit. Billionaires reinvest, and like, billionaires aren't necessarily a bad thing. I really don't think a lot of this problem is like a lot of billionaires get an unjust amount of hate for what they do, right? Like, most billionaires are new money, and most people today who are billionaires because they created immense amounts of value. Right? I'm not talking about Jeff Bezos. I'm not talking about Mark Zuckerberg. I'm talking about all the people in the middle. I'm not making a moral judgment of TikTok, right? Like, is TikTok as a company negative value? I don't know. I think people enjoy TikTok. This isn't what I mean, right? I mean the people who you contribute nothing. The people who contribute nothing to society. The people whose society would actually be better off if they didn't exist, right? The people who are just a tax. Like, I'm specifically talking here, a lot about all financial services, right? Hedge funds. You guys are scammers, right? Like, it's not okay. And like we have to like get to a point where, we kind of say this, right? Like you're not setting the prices of things, right? Like, that's a lie. I'm not saying Facebook's crap. I'm not saying TikTok's crap. Those things, at least, look, like, it may be a shitty product, but they've at least kind of built a product for people. I think they have shitty business models, and I think there's problems with them. And then, you know what? We'll even go like hedge funds, particularly, they've taken up all of these smart people, and they contribute no value to society. Yeah, Facebook has an AI research lab, and like, honestly, I think, you know what? Here's what I'll say about Facebook and TikTok, right? Like, they're somewhat addictive, but people do spend a lot of time on them. And people might say they don't enjoy that time, but like, I much prefer to look at revealed preference than to look at, stated preference. I'm not talking about the things you know about. I'm talking about every single person who works in administration. Right? I'm talking about every single middle manager out there. I'm talking about every person who works in like finance industries that have nothing at all to do with people, that provide no value at all to people, no value at all to society, and are just a tax. You know, in London they pay us way too much, but houses are also expensive and we all hate our jobs. Quit. You know, you look at... Go figure out how to produce value. And then also, you have a whole class of people who, I have no idea how they get money, but they're perpetual travelers. Right? This is another... You know what the difference is between children and adults? Children consume and adults create. Right? These people are grown-ass children. I don't mind poker players. Look. Poker players don't take money from me. The problem, if hedge funds only competed against other hedge funds, I'd have no problem with hedge funds. It's just a massive tax on the whole economy. The whole financial industry is a tax on the economy. Poker players gamble against each other. That's great. You know what? I'm not. Yeah. Bankers get $120K out of university. It's just too huge to refuse. It's fucking fake. I don't know who scammed you into equating like these numbers with any kind of like real value at all. The money is made up. The money is backed by nothing. You're playing for points in some guy's game, and the guy who made the game rigged the whole thing. Money doesn't get you girls. That's the dumbest shit I've ever heard. People who think that have zero luck with girls. You know what gets you girls, man? Talking to fucking girls. It's really not harder than that. No, money doesn't get you girls anywhere. This is the dumbest myth. You know who promotes this? Like club promoters. Like this is just it's just to promote. No one gets laid from clubs, man. You know, no one's like I went home, I met this girl at the club and I brought her home. This is rappers and shit lying to you. You know? And it's like, oh yeah, the club is just a way to scam men out of money. Like, oh my God, all right. I wasn't expecting ranting. Some women will go with any guy that has money. Wait, you mean like hookers? I mean, hookers aren't that expensive, guys. Like, you know, there's great hookers on the internet, and like, it's not that expensive. Right? Like, we're not talking like lots of money here. I think what you're confusing, I think you're confusing money and status, right? Like, yes, women, you know, you women do like status. There's 7 million ways to have status. You know, blue check on Instagram will do you more than money for women. Yeah, no, oh my God, incels. Well, are you allowed to talk about incels? Like, incels are the most self-loathing little fucks. Like, if you guys just want to, you know, back in the day, 10 years ago, like, a pickup used to be this, like, great thing. Like, it was like this thing. It's like, yo, how do you get laid, man? And, like, it turns out there's, like, ways to do it. And the biggest piece of advice is go out and talk to women, right? And now you have these like incels who are like, I'm this or I'm that, or women won't like me because this. No, women won't like you because you're a little bitch who stays on the internet and talks about how women don't like you. Yo, I own 24 3090s, Giga Chad right here. Women will never like you if you go on the internet and complain about how you can't get laid. We gotta put a title on this webpage. Let's put a title on this webpage. Cherry Computer. You know, does nobody tell you guys this stuff? Fucking victimology, man. You guys want to say, oh, this and that, and this is because I'm only 5'7", and there's guys out there who are 6'2". Shut up. You know? All right. What am I doing closing tags? Well, I kind of want to close those tags because then the whole thing is going to be the title in the head. All right. All right, we're done with the rant. What do you mean we have to talk to people? It's rigged, man. You know. You know, picking up women is actually one of the. It's like it's not rigged, and it can't really be rigged because it's very decentralized. Right? There's like lots of women out there. People are like, oh, well, this, and that on Tinder. Well, yeah, don't meet women on Tinder, man. Like that's a Tinder problem. Oh, it's in. You know, it's in. Oh man, you guys know it's my favorite. How to stop failing at life, quit. You know, you guys bitching about the bitches edition. Everybody should really read and internalize this. I'm telling you, like I found this when I was like 15, and this was like one of the most you know. Go where the girls are. What, you mean I should go out clubbing? Do you want to date a holla back girl? Fuck no. Then no, don't go out clubbing. You may not realize it, but fully half the population of this planet is female. You don't have to suck up to an asinine subculture that you don't actually appreciate just because there's some single girls there. There's single girls everywhere. Just do something you enjoy in public. Skateboarding, Warhammer 40k, whatever. I guarantee there will be at least one female there eventually. Where can you find this goal? Is that an uphill line? Quit bitching about the bitches edition. Hey, you know, what did Lord say? Maybe the internet raised us? No, it's not Cherry AI. It's Cherry Computer. We're building computers for the future. All right. Wow, I get too amped up from the rants, you know? We have hot tub streams on Twitch. What are hot tub streams? I heard about this. I got an email from Twitch talking about some new guidelines. And it's, am I allowed to show nipple? And that's the only thing that I was interested in. And the answer is, only if in a nipple-appropriate setting. All right, so this is the risc-v. All right, maybe we got to do meditation. You know, it's been a while. And I believe there's a time for meditation in cathedrals of our own. Oh, nip alert. Don't they teach this shit in high school? The schools are propaganda machines run by the government. You guys, like, you know how we had like all this propaganda during like World War II and during the Cold War and all that kind of shit? You know it never stopped, right? You know the propaganda never stopped. You just don't see it today because you call it normal. But, there's a lot of shit that's propaganda, man, and that's why they don't, teach you that in high school. Now, all right. Exercise 6, finding your soundscape. All right, we got a signal quality check on here. No. We're gonna meditate. I think I need to I think we need to wipe the sensors with a lightly damp cloth. I dated this girl. She's homeschooled. No, she went to a bunch of different schools. She was homeschooled. It's just crazy when you meet people who weren't brainwashed. This girl's a genius and could think clearly about society. Try to get the here we go.
For this calibration, find a comfortable position and close your eyes. Take a deep breath. Muse is now listening to your brain signals. Relax and let your mind flow naturally. Let any thoughts, feelings, or sensations simply pass without any kind of judgment. Welcome back. Finding a comfortable, quiet place to practice can make a big difference. With Muse, it's just as important to find the right soundscape to keep you on track. Our relationship to specific sounds can influence how we feel during a session. This is why Muse has different soundscapes for you to choose from. Let's explore the soundscape you've chosen for this session. When you're ready, get comfortable and release any tension you might be holding in your face and jaw. For this session, whenever you notice the sound get more intense, instead of reacting immediately, stop for a second and listen. Try to hear the weather as clearly as possible. Notice how intense it has become, and be with it for a few seconds. Then let go of the sound and come back to your breath. Ready? Place your attention on your breath now. Great job.
That was not my best one. I did okay. But the important thing is we're calm. Oh, I have something else for you guys. You guys know about ComicCon? We're gonna have to all get on topic in a little bit. I love the waking up app's great. This is Amuse. I did like all the good waking ups. But I've been out of practice with meditation lately. Meditation's not BS. Is the headband BS? Yeah. No, I mean, it definitely correlates. I don't know. I just thought it was a cool product, so I bought it. Yeah, no, I'm a lot more calm right now. Yeah, ComicCon. Yo, so we got 2 tickets. We got general admission, and we got VIP. It's gonna be good. We're putting a lot of content together to kind of present what Comma's been doing for the last 5 years. OpenPilot is the culmination of tons and tons and tons of work. And I'm hoping by kind of putting it together like this, a lot of other people working on self-driving cars will kind of realize how hopelessly behind they are if they watch this kind of stuff. After trying Tesla Full Self-Driving, I've become pretty confident Comma's going to win. Part of the reason I'm doing this is self-driving cars are still 10 years away, like true self-driving cars. I'm talking like level 5. I think we might just see them by the end of the decade. But the current amount of compute available is not big enough to drive, I don't think. So one of the goals with Cherry is to build accelerators for Comma. Right now, Comma, our devices have about as much inference. They're about on par with a B, and then our trainer is about on par with a mouse. I think in order to drive, you're going to have to get inference on par with a mouse and a trainer on par with a human. So I went over the Cherry, been working on the Cherry business plan a bit here. Cherry's designed with need in mind. We upload small risc-v programs into the iCache and let them run. So I think we've answered both of these questions. I've been texting with, we'll refer to him as the source, and some great ideas about really how to build this thing in such a way that it won't just be fast for the current neural networks, but it'll be enjoyable to program. Sometimes you'll program stuff and think of like what's enjoyable to program and think of what's not enjoyable to program, right? Like, does anybody find writing multi-threaded, multi-process things to be fun? No. Like, that's not fun. What's fun? Like code golf. Code golf is fun. Is Cherry now a serious thing? I mean, let's see. So here's comma very serious. Here's Cheapy, and Cherry somewhere in between. Thneed? Thneed is, it's a thing in openpilot to accelerate models. You guys can look. It's one of the other ways that we beat NVIDIA. So our first step is to build everything in this board with a 4x4x4 map mill unit. So, you know, this is only going to be at 50 megahertz. We're only talking 6.4 gigaflops here. This isn't going to be serious, but we also need to get forward-backward passes of these 3 nets are the 3 that we're targeting. ResNet 50 and BERT Large are in MLPerf. I took MLPerf more seriously, actually. I like MLPerf a lot. There's only 3 accelerators listed on MLPerf right now, and only one of which you can buy. There's the NVIDIA, which is the one you can buy. There's Google, which you can only rent. And then there's Huawei, which I don't think they're allowed to make any more of because of the TSMC thing. So we'll be able to train MNIST models right on here. And we'll see if we want to use this DDR RAM on here as well. That'll be the big address space that we can DMA into. And then after we've trained MNIST on here, hopefully in a few weeks, we'll buy Alveo U250s and a Linux computer, and then we'll put a Linux computer in the house. So this is not going to have, obviously, very tiny. I'm going to get the DMA to work over this Ethernet interface. I think it'll be easy. On here, we'll support DMA over PCIe. We'll have a 20 meg onboard SRAM. We also have 64 gigs of DDR4, and we're talking a 16 by 16 by 16 MatMul engine, and that will be 4 teraflops. And then on this card, I think this is where we write like the PyTorch port. This is where we make multi-card training work. And I'm hoping by the end of here, without even taping out a chip, we'll have something that's decently competitive on MLPerf with maybe not A100s, but maybe like 1080s or something. And then when we do the tape out of the Cherry 2, if we actually tape this chip out, I'm hoping to do it from like a turnkey place so I can just hand them the Verilog. I'm gonna do a tape out. I want to sell these cards for $1,000, and then I'm hoping that even with a lower power budget, we should be on par with a 3090. And one of the reasons we can do this is there's a few things about the 3090, right? So the 3090 is a massive multi-core machine. The 3090 has 6,144 cores. Right? The Cherry 2 has 1 core. But that 1 core has more teraflops than the 3090. So we're spending a lot less power on dispatch. We're also spending a lot less power on copying back and forth to RAM. So our cache is a good bit bigger. Not the A100 has a bigger cache. Actually, we might want to up this to 16 million elements because then we're on par with the A100 cache. And then, if we're here and we've sold 10,000 of these cards, we're on track to winning the AI chip market. At this point, we raise a large amount of money. We hire people who actually have expertise in taping out and experience taping out high process nodes. So in 12 nanometer, I'm hoping, we can just bring it to a turnkey place, hand them the Verilog, and be like, do the best you can to lay my chip out. But after the Cherry 2, if this really works and this really sells and these cards are good, they have PyTorch support, they support multi-card training, we're going to tile the core and go to a smaller process node. Cherry 3 is basically 16 Cherry 2s on one chip. A big chunk of shared memory between the cores, and that's how the cores will communicate. No fancy networking. They just have a shared address space and a big piece of DDR memory. So yeah, we're talking 16 of these matmul engines, and that would be one petaflop at 1 gigahertz. And then we have a petaflop chip. And a petaflop chip where we can actually feed it from the SRAMs. And that goes to a few reasons as to why that's possible. So our goal with the Cherry 3 is to build a 300 watt card that's on par with a DGX A100. We also will get some, okay, so you say like, how is this more power efficient than NVIDIA? So we are using a slightly smaller process. We won't be thrashing. We have a lot more memory on the chip, so we won't be going out to the external memory nearly as much. The control logic is much smaller. Yeah. And hopefully, yeah, we can make one petaflop work. This is pushing the limits now of what's possible with like tops per watt. But I think if we have this, we'll be able to get all the best people to do it, and this will be by far the best chip in the world. Is 16 gigabytes not low? Yeah, we can maybe stick more memory on it. I mean, the nice thing about that is that's like just off the chip. GraphCore claims 10x energy efficiency over NVIDIA with the local memory approach. Yes, I mean, we're using the same 10x, right? Like, it's NVIDIA's memory that's killing them because NVIDIA's memory isn't really designed for this. How do we convert tinygrad to binary for Cherry? You'll see. I'll start, like, you'll write these kernels in risc-v, and these will be like HPC kernels, and you just load it into the core. Well, I don't know what Jim's doing in TensTorrent. As for what TensTorrent's doing so far, TensTorrent's talking about weird researchy stuff. They're talking about things like sparsity. They're talking about, this is a bad idea. This is a bad idea to talk specifically about like certain kinds of, of models, or talking about like the future of what models look like. Just leave that to the researchers. The job of the compute builders is to build very flexible, easy to use compute that's available. We don't need HBM. You don't actually need that much RAM going out, that much bandwidth going out to the things if you have a lot of SRAM on your chip, right? So I'm talking about 288 megs of SRAM on the chip. And this is all for training. But yeah, we can do branches. I mean, the core is a risc-v core. So like, okay, fine. The Cherry 3 will have 16 of them, but like still we're on par with like a normal like multi-core computer. We're not talking about thousands of cores here. We're building a single core risc-v superscalar out of order, right? Targeting like, I shouldn't even say 1+ instructions per cycle. I should say we might even put 2 matrix multiplier engines in this thing. Google TPUs are just 2x better than NVIDIA. Well, which Google TPUs? Google TPUs were only 2x. Google TPUs were 2x better than NVIDIA on a 16 nanometer node. Right? So like NVIDIA's, down on like a 7 or 8 nanometer node, and the Google TPU V3 on a 16 nanometer node was 2x better than NVIDIA. So yeah, the Cherry 2 on the 12 nanometer node should be like on par with NVIDIA. I think my targets for power may be a little ambitious. I do recognize that. get an easy 10x over NVIDIA is not to rip everybody off in terms of price. All right, like we're not looking to rip people off. I want to build all this Verilog open source. Here's a vector risc-v core that I'm planning to work on. Won't other companies use my IP? And what will they use my IP for? Making AI accelerator chips for the world? MIT, bros. MIT. Think about it like this, right? You're only on this planet. I think it's becoming really obvious now. The way that you get more is not by taking more for yourself. If you live in a world that doesn't have technology, this is obviously true, right? The amount of, whatever, we're hunting deer. The amount of deer the tribe kills is fixed. So what you want to do is try to make sure that you get more deer with respect to other people in the tribe. This isn't how the world works at all anymore. Everything that's made my life better is not because I have comparatively more money than I used to have. It's because the things you can buy are better, right? No amount, we can talk about 3090s, no amount of money in 2000 could buy you a 3090. Now you can buy it for just, $4,000 on eBay. The world isn't even close to zero sum, right? So you're like, okay, so why do you give it away, right? So what's my goal? What's my goal in life, right? Like my goal in life has nothing to do with, stacking gold bars in a safe or something. I mean, it has to do with, again, I have more. You see this Red Bull, right? This cost, I think it was $2.50 at 7-Eleven, right? If I was a billionaire, I'd drink the same Red Bull. It's interesting like that, right? It's not like I can buy a 10x better Red Bull for 10x more money. Yeah, I hate graph stuff in TensorFlow. None of it's graph. I hate graph stuff. I don't want to do any graph stuff. I want to build a processor. A normal computer processor, and I want it to execute things sequentially, like a normal program. No, you're not rich enough to know about the 10x better Red Bull. I know billionaires. I've hung out with billionaires. I've met them. I've seen what their lives are like. Right? Like, they're drinking the same shit, man. There's no market above. Look, I go to this coffee shop. I pay $5 for a latte, There's no $50 latte market. Oh, why is the last step to sell the company? So you sell the company for two reasons. One, because, you have to pay the investors back. And it's not really like comma. Like solving self-driving cars is very pivotable to other things. After you've built the Cherry 3 and you've won the market, it doesn't really matter anymore. Right? You can sell it to Intel, and even Intel would have a hard time screwing this company up. I mean, they would after 10 years, but for a while they'd be able to launch the Cherry 2, the Cherry 3, the Cherry 4, the Cherry 5. And so it doesn't matter. I mean, sell the company, right? Flip it. And it's not about really making money for me. It's about alleviating giving me capacity to work on other things. So that's why you flip the company. Right? In some ways, if you don't take their money for it, they won't think it's valuable. Can you counter node size with density? No, money is not resources. Money has very little to do with resources today. you see this. I mean, you can see this in, could Waymo build openpilot? Well, could Cruise build openpilot? This is actually a better one. Right? I know less about, Waymo's Sebastian Thrun, Waymo's the old days, but like, when you look at Cruise, there's a Kyle Vogt, Lex Friedman interview. And Kyle Vogt says that his original idea was comma, and then he lists 3 reasons why comma is too hard. Right? One of them is about needing to support many cars. Right? This is the first one he gives. He's like, well, so, we built Cruise. Cruise was originally going to be an aftermarket add-on. We built Cruise, but it only supported the Audi A4, and it turns out not that many people have that car. Right? Well, so what? OpenPilot supports like 115 now different cars. The second one that he talked about was about the fact that car manufacturers may change the firmware, and you'd have to deal with that. Well, again, we just looked into that, right? And I think he also talked a bit about just the difficulty of talking to all the different cars and reverse engineering them. It's we did that, and we crowdsourced it. Yeah, I mean that was, and then he said something about I'm not even sure. I mean, maybe he said safety, but again, that's not these are all problems that you can just overcome. Right? As far as we can tell right now from the data, OpenPilot seems, now this may just be the OpenPilot user, but they seem to be about 2x safer than the average driver. Right now, you can't really separate OpenPilot from OpenPilot users. But so safety, car support, and reverse engineering, done. Right? Sorry you couldn't do it, Kyle. What did you do instead? You built the Cruise Origin, right? But Waymo's lifestyle commercials, it's laughable, and that's what I made fun of them for. So just to counter your idea that money is resources, on our Slack today, someone's like, "Are we sure Waymo's not a front for something? I mean, what is? Are we sure this $3 billion not going to some other operation? Because it doesn't make sense." My plan is to release the chips as PCIe cards. Inter-chip bandwidth is overrated, assuming you're training these normal size models where you can fit batch size 1 on a card. No more self-driving cars. Yeah, so my goal with these things is to, PCIe cards. I mean, I say PCIe here. Do I think we're moving closer toward the goal I had in my South by talk about culture? No, I don't. I think 2020 has... I put it on my blog. I wrote a rap song in 2020 and thought I'd explain the lyrics here. After watching 2020 happen, the current group in charge should never be in charge of anything ever again. You guys know I'm down to get behind the revolution. I'm not, I'm a on the spectrum kid who knows something about computers, right? Where's Caesar? I'm waiting for Caesar. I'll join his army. Where would we manufacture? Having a single CPU with an additional matrix multiply block sounds so awesome. Yeah, I know, right? Doesn't it? And we're texting about I wanted to build these these 3 registers if you look at my tinygrad model, like my tinygrad model is here. This is my. If you look in extra cherry, it's what I have. So it's here. Like my model, I put like 4 registers and I like labeled them stuff, and then I'm like, yo, like what kind of fixed function machine crap is this? Why don't we just have 32 registers? And each register is 1024 words. I think it's beautiful. Okay, so let's see what's in all these vector extensions. But yeah, this is my rough emulator for the architecture. It supports loads and stores. It supports this set of binary operations. So this is the ALU here. Add sub, mul div, mulac. Mulac's actually going to be taken out. It's just going to be a multiply and then an add. We got a, what are we, a sysc instruction set? Nah, bro, this is risc. You don't have mulac, you have mul and add. And then like, yeah, we'll take things like that out and we'll give it 32 general purpose registers. Work from home is an absolute joke. Any company who thinks you can build any reasonable culture with people working from home is so misguided. Cherry Computer is going to be in person, either in San Diego or LA. When it's time to hire people, I want to get like a beautiful glass office. You know what I mean? So no, Comma doesn't hire remote, and Cherry will not hire remote. If you're serious about working on something, show up at the office. Oh yeah, programmers on Reddit say otherwise. Yeah, well, you know what? They also have enough time to post on Reddit. No, work from home's not fine. Widening FP add and subtract. Am I working from home right now? Well, yeah, there's no office for Cherry though. Comma's all working. I went to the office today. No. Most of California is not San Francisco. Huh. I mean, this is interesting, right? It's like, I guess I didn't really realize this, but oh, so, okay. Here is an example actually of where work from home can work, right? Like, work from home can work if you're working on a project that you're self-motivated for, right? Like, if you're contributing to an open source project for free, you can do that from home. You can do contract work from home too. What you can't do from home is salaried work, and certainly not work when there's equity involved. For the IEEE floating point standard, I think we're going to not implement rounding to match IEEE exactly. Yeah, the vector stuff's changing. That's fine. I just kind of want the basic idea. I've never really looked at a vector instruction set before. My only real experience with it is like Intel's AVX stuff. I've never even like coded in ARM Neon, so I don't really know what that looks like. I should probably understand it first. This MapMul engine would do convolutions versus some strided offset addressing control. Yeah. Yeah, there's TF32. We're implementing TF32. So on these two, we're actually doing TF32, but we took one bit away from the Mantissa because all the block RAMs are 18-bit block RAMs and not 19-bit block RAMs, and I'm not going to create a whole other block RAM just to store 1 bit. Though actually, it's less of a problem now that I switched to big words. So we can reconsider that, and maybe we will go to 19-bit. Yeah, we'll reconsider 19-bit. This is the, yeah, there's a lot of pieces to this project. So it's good to kind of understand them all. So this is in Twitch Core. This is by memory, and like how much striding potential we get is controllable here. So like the question is kind of one-dimensional strides or two-dimensional strides, and I've kind of settled on one-dimensional strides. Two-dimensional strides require too many addresses to go into the SRAM. But yeah, I mean, actually, if we just set bits to 19, that should just work. Let's see, I have an 18 here. Let's make bits an input parameter here. Every other video, I see the same hose. Let's get rid of the strides. Go strideless. Every other video. You know, you guys know that song? Remember that song? Yeah. All right. So this is like my emulation of my my memory. And then we can actually go in here, and I should really rename all this to cherry. Parameter bits 18 bits. So now that's with 18 bits. Let's try it with 19 bits. Oh wait, no, that's not actually right. We have to go to the test bench for that. What? Okay, I think that's 19 bits. Yeah, that should show at least one more hex character though, right? Oh, I said it's okay. I said it's a 19. Ah, there we go. Port dat w expects. Oh, this is a good way to find bugs. Reg size equals bits times bits. Bits times size times size. That seems right. Port 5 of risc-mem expects, oh, it's this one here that I didn't do right. No, bits is right there. Oh, did I not pass bits into the memory? Ah, I didn't pass bits into the memory. There we go. Boom. Okay, now it supports 19 bits. Now let's see if we can synthesize that. And we'll see how many BRAMs it uses and stuff. All right, so now it's creating one block RAM to store 4 extra bits. But actually, that'd be cool if this just worked, because it's really less of a problem once we get to. Yeah, look, I'm using. No. Did this just work? I don't get it. Seems like adding new devices to PyTorch is fairly simple as well. Yeah, it's not that hard. Oh, I didn't change it to 19. Okay, let's see what changes. Did I get float add finished? I did actually, yeah. Floating add works. You can check it out. It's in this repo. Okay, so look, it switched all to BRAM 18s. Didn't use any BRAM 32s. Wow, that's a lot of BRAM 18s. That can't be right. This used 65% of the BRAM 18s? Never mind. Never mind. 19 bits was a mistake. Go back, boys. Go back. Did I get my floating point addition to work? I did. Where did I write that? tf32.c? Yeah. So this is add. My normalizer's a little stupid. But that's my floating point mul. That's my floating point add. So I understand what's kind of there. I also read this good paper about it. That shows you like if you use like the DSP, how many LUTs, how many registers you need. Yeah. Wow. Adding and subtracting need a lot of LUTs. Iterative combined. For multiplication and addition and subtraction. Oh, see, that looks pretty cool. It only uses one DSP, uses that many LUTs. Have I tested my core with risc-v tests? Yeah. Yeah, so I went through, I don't have a test harness yet. By the way, you know what, I'll make that an issue. If somebody wants to file a, okay, so I made the test work, but right now you have to go in and like manually edit the test in the test bench. It's actually not even in the test bench, it's in risc. It's in CPU. So if you go in CPU, like this is the store test, right? And then if I want to run the store test, I can simulate, and if it says trap 1, it means that the test succeeded. And you can see if I like go and let's break the store function. All right, like here we go. Let's do load, do store. Okay, we'll break the store function. We'll take the data out. All right. And well, okay, that doesn't even finish. Gets trap 0, but let's say like we make a typo here and put 2 instead of 1. See, trap 7. That means the 7th test failed. 1 means they all succeeded. So if somebody can write something that that goes through and test them all, I would appreciate you. Mo Asker, I appreciate you. That's why you're a VIP. Every other video, I see the same hoes. risc-v formal. What do they do their formal verification in? Cool. I'm interested in this too. I mean, so it really looks like what we're building. I mean, tests are good too. You want tests, you want formal verification. Really, what we're building is a super powerful risc-v core that's also just a great risc-v core on its own, but also has this insane vector engine attached to it. So it's actually, I shouldn't talk about, like, that's not what I mean by work from home is the problem. Work from home's only the problem if you're getting, it's an incentive problem, right? If you're gonna pay people with salary or with equity, they can't work from home. Right? Like what they're doing when they choose to work from home is they're prioritizing their lifestyle over your business. And like, that's great. And you know, you can scam companies out of that, but like, that's not, you know, like we're here to build something, right? No, it's not even that. Like, if you're contributing to these things from home, well, you're contributing because you want to. And if you're contributing because you want to, we don't have this incentive alignment problem, and then you can do it from anywhere. Like, yes, fuck any biz, live your lives. What do you want to do? You want to, travel around from place to place, and you want to, like, consume things that other people have created? The only things that make going to these places good is because there's people who stay there and create value there. Like, something that starting a company has taught me, and that I wish, and this is the kind of stuff that I blame on, like, how hard they make it for small businesses and how the monopoly stuff works, is that people don't feel like they're an owner of anything. And if people don't feel like they're an owner of everything, their attitude is all going to be fuck it, right? Like, the saying when you rent a car, it's like, never gentle on a rental, bro. And like, yeah, I live that life, right? Like, live that life. And, people who don't want to create value, like I said yesterday, bullets are cheap, right? So is fentanyl, right? It's cheap. The employee is not an owner because the CEO or boss can fire them at any time. Well, of course, but if, you have equity in the company, you're an owner of the company. Can you briefly go over why you should not start a business? I mean, if you're trying to start a business, you're already doing something. You know who should not start a business? Anyone's like, well, I really want to start a business. I just need to figure out which business to start. Ugh. You can take a, midday, you don't have to, like, the offices shouldn't, like, tell you what hours you're expected to be in the office. Go to the office whatever hours you want. You want to take a nap in the office, take a nap in the office, right? It's all fine. What has been the progress today so far? Well, we made a tiny tweak to the memory, but other than that, not that much. Okay, so we're gonna write the reduce ops. Now, the reduce ops do this thing where the vectors in this machine. Maybe we should write some docs on the instruction set. In FPGA. You know what? We'll say units, right? So we're now thinking of a 32, 31 vector registers. All right, we of course get the 0 vector register. Then we have a matrix engine, which is something like matmul, Okay, so these registers are 1024 element, 19-bit TF32 wide, and you can effectively think of them as 32 by 32 matrix. So they're actually, should we call them matrix vectors? So the vector can be both a vector or a matrix, right? Like, depending on how you think about it. we'll call them vector registers, but you guys understand like what I mean, right? Like you can view it like this, or you can view it like this, right? So we have this special instruction called matmul. And then of course this number can change. We'll say size equals 32. So this is, you know, size times size element, the size by size matrix, right? So this is the matrix engine. This is the vector engine, ALUs, we'll say 1024 ALUs. You know, add, sub, mul, div, pow. All right, guys, now it's on topic time. We need everybody to focus. We need focused energy. Focused energy. Movement. Oh, we have move. Load store engine. Load v0. I even have some more notes about this somewhere. v0 address stride I'm pretty sure I can stick both the lengths up here. Actually, well, so I don't know if the lengths make that much more sense. Well, I guess we can put them there. That's kind of nice. Okay, so this is something like, you know, let's say we're loading into v0 and this is like R0 and R1. Well, actually, it can't be 0. Sorry, I shouldn't be using 0. Because 0 is the 0 register. Something like this, and then let's just look quickly at the risc-32 guide. Up here. Over here. This is more vector shit. Squeeze back. Here we go. I think this can actually. Oh, well, they're called X. Okay. Not called R. And these did call their vector V. I mean, I should like get more familiar with risc. It's like I don't know which ones are the like. What's the I, J, and K of you guys know I, J, and K from like way back in the day? Which registers are your I, J, and K registers? Let's just say X1, X2. And this is actually only stride Y. No, it's not. It's you're not right. They're not even called R. They're called X. Oh no, I think you might be right. No. Wait, hang on. I shouldn't talk so fast. Because there's like stupid renamings of them. X0 is they have like names for all the registers. Do we have enough bits for all the information in the instruction encoding? Yeah, because these are actually registers, right? So this load is we'll look at it. It should be fine. CPU.py. Are R. Oh, I think they're just T's, the T ones. So those are registers. So when we look at the load instruction, I actually kind of wrote this out. Where did I write this? I had notes on this. Where did I put Maybe in Twitch Core. Maybe in here? No. That noise is annoying. Oh yeah, so like this. I don't know. We can just look. It's like, what's a normal load instruction? Okay, so they have base, depth, and offset. Yeah, I mean, I think we can use the same instruction encoding as like, it's like a combination of those two. No, I've seen them, actually. It's called something else. Yeah, it's an R-type instruction. So like, this RD is the vector register, and then these are these two registers here, which contain that stuff and contain that stuff. A MIP-style processor with a matrix accelerator attached. It's the PS1. We also need something called the permute engine. As store is just this, but the opposite. Right. Oh yeah, I shouldn't really be using those. We'll just call them T. They are the return address and stack pointer. You're right. So let's be a little better about. Let's respect the risk. Temporaries. Okay, we can just call them T0 and T1. So for the vector engine, we just have stuff like, you know, add and we should also be able to support things like this. Permute. Interleave, shuffle, impact, low and high. Yeah, it's, I'll copy that. Might be too complex for RISC. Well, it's like a permute engine. So we can also, like, again, this is like, I want to do like a whole superscalar on this processor. So we'll be able to like run multiple of these at the same time. Let's see what we can glean from the RISC vector spec. We already gleaned something, which is that we're going to need to also support vector scalar add. Like, I'd be cool with something that's just like transpose, you know? Wait, RISC doesn't mean few instructions. It's more the load store architecture. What do you mean by that? So part of what makes this stuff so confusing is they have like these very complex memory models for these things because it's supposed to interoperate with the main memory. I'm not trying to interoperate at all. I have my own memory system for this accelerator, and like that's just how it is, bro. Vector. What is this VM? Why do they have VM? Why Let's understand this. What's VM? Can someone explain it to me? Oh, CISC has memory register ops. I see. Yeah, we don't have any memory register ops. That's a cute distinction, actually. What's VM? Do you see VM being used anywhere here? Yeah, I can disable the noise with the mute button as well. No, I like the noise when I'm alone. I just don't like it with you guys. I don't want to disturb you. What is VM? Why don't they tell me? Virtual machine? I don't think it's that. Oh, it's just like 1 bit. What does this bit do? That's all cool, man. Like, I like these. I want to steal these. Specifies whether masking is enabled. What's mask? I hate masks. Masks are stupid and don't do anything to prevent corona. Can you say that now? Do we all accept that yet? Or, you know, is this still controversial? VSpec. Oh, this is better. VM masking. Vector masking. Element operations that are mask off never generate exceptions. Guys, all right, never mind. There's the bait. You guys shouldn't take the bait. I shouldn't take the bait. Don't take the bait. Wait, when available. Do I need this? Why do I want this? Why is this a... What? Oh. Wait. Someone probably very smart came up with this, so I should understand it. Only where v0.mask equals 1. No masking operator is specified. What? Specifies whether vector masking is enabled. I mean, this seems kind of like what I'm trying to do here with length X and length Y. But it's even cooler if we can just put it in a mask. Where are these masks being held? Where's the mask held? Is there like a mask in each register? I'm trying to understand where the mask is being held. I get what it's doing. I like it. I like it. And that's actually so much nicer than my length crap. Man, smart people came up with this shit. Yo, I literally just want to steal all this vector stuff. We're just going to implement vectors, and we're going to take over the world. Section 4.6 of the vector docs, okay? A vector mask only occupies one vector register. Oh, is it a special register? Is there a special register called the vector mask? Or basically what I'm asking is there multiple... Yo. Love these people. Man, this guy. I met him once. He's at Berkeley, right? Yeah. They showed up at one of his classes once. Man, who'd have thought? Gonna go down in history. No, the spec is not ready. I just want to say, like, writing that risc-v processor made me think that, like, risc-v is just like made by geniuses. Where the least significant bit of v0 sub I equals 1. Oh, v0 special. Is that what it means? Does it actually mean v0? This is just beautiful. I love risc. Wait, it's actually v0 though. But so what you're telling me is every register is actually affected by v0? I'm not sure I agree with this. Vector mask operations. Vector data movement. Insert GPR into vector. I don't actually know if I need these kind of things. Oh yeah. See, like this is all the shit we're not gonna have. Oh, it does support FMAC. Okay, fine. I'll support FMAC. Just because they support FMAC. Yeah. We're not supporting any different data types. We're supporting one data type. This is a 20-minute talk. The slides have a whole thing on masked operations. Wow, we're learning so much, boys. Gotta steal more from risc. risc-v's gonna change. Just watch it.
What are you doing?
It's cool, I'm just looking.
It's too much machine for you.
Yeah?
I hope you don't screw like you type.
Has a killer refresh rate.
P6 chip. Triple the speed of the Pentium.
Yeah, it's not just the chip, it has a PCI bus. You knew that.
Indeed. Risc architecture is going to change everything.
Yeah, Risc is good.
Hey, remember when there was still hope for the future? Risc architecture didn't change everything. Hack the planet. I still don't understand this mask shit. Is this actually the V0 register? Masks are stored in regular vector registered. The LSB of each element is used as a Boolean 0 or 1 value. I don't think they actually mean okay, so I think there's actually a mask register for each see the third paragraph under 5.3. Vector masking. Okay. Masking is supported in many vector instructions. The destination vector group cannot overlap. Is always supplied by vector register V0? I don't like that. I almost want to buy this book. Just kidding. But I don't like this V0 crap. You're telling me I need a port in my register file to read V0? Okay, fine. V0 special. What's the difference between a mask and an unmasked vector? So in earlier proposals, VM was a 2-bit field that provided both true. Oh, they're really struggling with the mask. This is a nicer way to think about it though. And like maybe we can like, are there mask generation instructions? Oh, but this is super nice. Oh, and then like to load in 0, I just have like a mul. I can just do like move from, yeah. So like I can move vector, but I can also move scalar. Load 0. Yo, I'm loving this. X0 is the dedicated 0. Yeah, normal risc, yeah. Vector configuration instructions. Wait, what? It supports stride? They know about stride? Indexed. Whoa. Shows video register holding address offsets. That all sounds very complicated to build. What's indexed? Unit stride. Strided. What's sum up? Yo, but I like this. We're gonna steal this. It's not the strides you think. It's strides words between the lanes. No, what do you mean? Oh. It's not memory stride? No. It's exactly the stride I mean. Yeah. Does it have vector of indices and base address like Intel vgather? What's vgather? So basically we just have to implement this. Yeah, this is, wow, this is like what I came up with. Except they thought about it a lot more than I did. Specify size of memory elements. Oh, and distinguishes from scalar, I see. Cool. And we'll be inspired by this, and we'll steal some stuff. I don't think the immediate stuff's useful at all because we can't fit 19 bits. Am I sure I shouldn't be using 3,000 byte instructions? Yo, how am I going to get an 8Y decode path when I have 3,000 byte instructions? We have an 8Y decode path, boys. We need to build a super wide, super scalar, out of order engine. It's going to be blindingly fast. We'll have to write some comparison crap. Well, we need a comparer engine. By the way, is that not the ugliest register name you've ever seen? YMM and XMM? They do name their vectors just V, right? Because otherwise I'm going to be upset. Where are my registers? Vector registers. Oh, yes, V. Oh, beautiful. CSRs, don't need any of those. Read only VL CSR. No, I hate CSRs. I didn't write any of them because they're useless. Oh, someone might detect if they're running on an official Cherry hardware or not. You miss ARM registers. Yes, ARM named their registers correctly. I do not like what RISC did. They like have all these weird aliasing names for them. Like, I'm just going to call them X0 through X31. It's like MIPS. Racks. Racks on racks on racks. They're called major opcodes, I say. Format for vector arithmetic. And that's where I choose which it is, and then func6, I imagine, decides which I'm doing. Vector configuration instructions. What's a configuration? Strip mining. Do you guys get what these things do? Hints for vector chunk sizes. Oh, we don't care about that. Like, can I see what's in those func6s? What are my options? No. We like masking, even though that's only V0, which is weird, but we're fine with that. How do I like set up a mask? I don't know. Wait, so yeah, where are all my ALU options? Dynamic selected element. Visu. Oh, that's reserved. They're formally reserved. Okay. Well, I hate CSRs anyway. I can't believe I'm looking at CSRs again. Vector arithmetic. What's in the func 6? Double width source vectors into single width destination vectors. Narrowing right shift arithmetic. Vector fixed point. Vector single width. Here we go. Vector floating point. Okay. Can somebody explain to me what widening means? What's this? Okay, we can do add, subtract, multiply, divide. And then we can do fuse, multiply, accumulates. Multiply, subtract, accumulator. Maybe result date. Oh, it's about data types. Oh, I hate data types. Ugh. So much time is spent dealing with data types. Why can't everybody just agree that 19-bit floats are the best? And that nobody needs bigger floats? And, floating point square root. Okay, maybe you don't have a norm. Maybe you don't have a power instruction. This is the unary vector vector. Oh, do you want an exact square root or do you want an estimate of the square root? We have to have both these instructions. I thought this was risc. That's the most sisky looking bullshit. What do you mean? 19-bit floats everywhere. Oh. Reciprocal estimate. Okay, and these are all the compares. To help operate on mask values. Each element in a mask register is a single bit. VM set. VM move. Find first set. Set. Wow. Okay, this is so complicated. Oh, how much did I owe to pay for this? You don't need FP32. Scalar move. Slide up and down. Wow, is this like some like Drake? Slide up instructions, slide down instructions. Wait, no, I just moved a lot. Value in VL specifies the maximum number of destination elements that are written. Where's VL? Do you see VL? I don't see VL. Slide one down. Register gather. Okay. Wait, this can support arbitrary scatter gather? Isn't that really hard? So if I have 1024, that's like a 1024 by 1024 mux. Okay, we can't support that instruction. I don't know. Okay, I'm done reading the vector thing. Important things we learned is the masked execution instruction, helper function instructions to load size into mask. Pick the best parts from the spec and roll your own. We're not really doing general purpose compute. I mean, what we're doing is kind of interesting. New instruction set. V, little v. Yeah, let's do a little v. We'll rename units to instructions. I mean, NVIDIA is designed very differently from the thing that I want to design. NVIDIA is many tiny cores operating with this, no, sparsity, things like sparsity just piss programmers off. Because a programmer like I'm pissed off, it's like, well, all right, so how do I make my net sparse? And I'm sure I can read some academic PhD bullshit paper about like using sparsity and backpropagation. And then like, can I set sparsity equal to 1 in PyTorch? No, I can't. Anyone who's actually using this stuff in practice like hates all that new academic crap that comes out. DeepMind came out with a paper where it's like, you don't need to use batch normalization. Just use this crazy extension to stochastic gradient descent. And like, that's great, but like, batch normalization's in PyTorch. Okay. Let's implement the max instruction, and then I think that's today's stream. But you know, as of today, Cherry Computer is very real. Cherry Computer is super real. You guys saw the website? You know, it wouldn't have a website if it wasn't real. Don't you wish you had a choice? Cherry Computer, custom card you can buy. We should put the price. For $999. Card for sale 2022. Job in office in San Diego in late 2021. Wait. You do understand that there's a file on my computer. Don't you wish you had a choice? high-speed training with PyTorch. Wow. We don't need Cherry Computer. That's kind of redundant. Maybe we'll include a link to the blog post. Except on the Appeal Day, yeah. Why is inference hardware different from training hardware? Because inference hardware relies on very static, shitty memory access patterns. I'll just write learn more. Sorry, I'm too kind of tired of the code. I thought I was gonna write code, but we didn't really write code. We just read things, and we made this beautiful website. Arbitrary stride would be useful for nearly all basic DSP algos. Oh. My rationale for creating this. Oh, the $9.99 will be the ASIC. I'm hoping we can have an ASIC in like a year if I actually do this. I don't know. There's a lot of stuff to do with comma still. Is this something I should do? Am I going to regret this? Is this going to be fun and easy? Yeah, it's a realistic price. I mean, the first card is not going to be, like, that great. I mean, it's not that it won't be that great, but, like, it's not, like, I don't even want to have, like, onboard memory. I just want to use the host memory and the SRAM. Will this be fun? No, I'm not doing pre-orders until we actually have a card. I'm not even buying myself one of those big Xilinx boards until after, do you have to use iVerilog for the PR? Oh, it's in Vivado? No, I don't have Vivado. We can't use Vivado. The real reason is fucking NVIDIA. I mean, that's kind of true. No, this is going to be fun and easy, boys. It's going to be fun and easy. The future is an unmodularizing. Isn't that AMD's motto? Adaptiva Epiphany. No, you guys, you see the problem? Oh, well, at least they got rid of all their stupid cores. Some gigahertz. Wait, what? He got bought by the government? He made his chip and then the government stole him? god, this cell is so bad. All these things are so bad. One big core. They made him an offer he couldn't refuse. Yeah. No, but like this is bad. This is a bad idea. I don't want lots of little cores. I want one big, powerful core. Big chip, very big chip. Yeah. You want the parallelization to be done in hardware. Well, yeah. I mean, ideally, I don't even want parallel. Like, I just have, as far as I can tell. Here, I'll show you. I was playing with the, sorry, I was going to code tinygrad today, but I'm tired. So this is the simulator that I have. The simulator says that we can run the forward pass of an efficient net B0 in half a microsecond. Now that's with a 32 by 32 matmul, and I'm getting 72% utilization. So this is assuming one instruction per cycle, which we might even be able to do better than as well. Like it's assuming like I'm not doing any pipelining between like the loads and the matmuls and the stuff. Where, oh yeah. So if I change it to be, let's say, 8 by 8, it takes a lot longer. Because now each instruction is doing an 8 by 8 matrix multi. Like that's basically the size of the registers. You know, I said the registers were 32 by 32. So we're going to get better utilization, but it's going to be slower. It won't be this slow. This isn't actually in real time. It'll be a lot faster on the real chip. Yeah, so that runs now in 8 milliseconds. And like we can set it to like a middle size. Yeah, see what I did though? I wrote the software before I made the hardware. We'll get some test kernels for it and stuff. Yeah, so this is, so like it's taking 1.8 milliseconds with the 16 by 16. So this is 4x more flops, and we're still getting good utilization. So like when you build like all those cores and GPUs, you can't do things like out of order superscalars and, you know, like good branch prediction and all that kind of stuff, because if you did that, you'd burn so much power on each one of those cores running that stuff. But because this core has such a powerful matrix multiplier attached to it, that's going to blow your power budget out anyway. So feel free to use all this nice stuff that makes CPUs good. Yeah. 72% good utilization? Yeah, 72% is great. Anything above 50 is great. Power budget? I mean, this... So this card, I should be able to fit 496 multipliers on, and that gets me 4 teraflops. Who's the target market for this card? Every person who wants to train neural networks. Every person who bought a 3090 for training. I mean, this one, there's no real reason to buy this over NVIDIA unless you want unless you like open source and you know you want to like play with the cool one that's open source and fun. This chip is the one that's actually like, if we're competing with NVIDIA's $200,000 machine with a $2,000 card, like, do you want a $200,000 machine or do you want a $2,000 card? All right, and then one petaflop. So then if I have a rack of these cards, okay, so I put like 8 cards in a machine, maybe I have like 5 machines in a rack, like we're talking like 40 cards. 40 petaflops, you know, with 50% utilization, still that's a human being, you know? I want to fit a human in a rack. Well, it's not on par with the 3090 for graphics, but it should kind of be on par training-wise. The 3090 won't be obsolete, so NVIDIA will come out with their new thing. I mean, NVIDIA, the Cherry 3 will be competing against NVIDIA's next generation, but like, you know, 1080s are still nice cards. What are Alveo? Oh, they lent out Alveos of the Xilinx. I mean, I'll buy one once. Our goal, and I'm not going to do a lot of this coding on the stream. Coding on the stream is more for like just what's flashy. Would it be a mining card? No, it's not a mine. No, it's not good for mining. None of these operations are remotely what you want to do for mining. Another advantage, we don't have speculators buying the cards. Yeah, unless you can turn your SHA-256 into map mall. I mean, it's a really wide floating point vector unit. It's totally useless for crypto. Do I think I could kickstart the ASIC? Yeah, probably. If I got this thing training and I got like a good synthesizable open source risc-v, I'm pretty sure I could kickstart the tape out of the ASIC. Like, and this card is a $7,000 card, and I'm confident that I could at least match the performance of the $7,000 card with like a reasonable small chip tape out. Work SHA-256 into those mullets. Oh yes, obviously we need the SHA-256 engine. Yes, I see your complaint about the GitHub issues. We can get there. I don't really care that much about that. Right? Doesn't it sound amazing? You know what? I don't want to make it. I want somebody else to make it. Why doesn't somebody else make it? You know? That sounds nice. What are ML Gray problems? Is this a thing? No. Nah. Yeah, nobody wants to make what he thinks the world needs. All right, guys, I'm hoping one of you can do it. I didn't make the reduce ops work. The reduce ops are kind of like the binary ops. I'm hoping somebody can contribute that to tinygrad so I don't have to. No, like Capital doesn't help me with any of this stuff. Imagine instead of, you know, me sitting here designing a chip that I like, this whole thing was designed by a big committee. Capital only helps once you have a minimum viable product you would like to scale up. No amount of capital helps you find a minimum viable product. I don't know what gray machine learning is. If a competitor made a compelling chip, would I stop? Only if it was open source. Well, that's the other thing too. Like, I want this whole core to be open source, and I hope, you know, everybody just starts sticking it on things. How do I know what direction to take the MVP in? Okay, you guys see? It's very clear. I want this, but don't you wish you had a choice? You build this, but, you know, cheaper and not controlled by a monopoly, and, you know, there you go. There's your minimum viable product right there. Right? Oh God, I've been thinking about starting an AI company, a chip company for like a couple of years now. No, I don't know. Like a year ago, I thought about it quite seriously, but it wasn't ready yet. Like it wasn't time yet with comma. Economies of scale, like, they're useful if you're trying to get the latest tapeouts. If you're trying to get the absolute, like this card only works in large scale. But I mean, I think you'll have the large scale. No, Adaptiva and GraphCore built multi-core things that are really annoying to program for. What we do if we're attaching binary blobs to our kernel modules. Well, yeah, I mean, this is where we, you know, raise money and like really optimize the core layout and make something like really good. This chip's kind of a hobbyist level chip, and that matches approximately the Xilinx. The stats on the Cherry 2 might be a little bit overstated. I mean, yeah, there's no way we're actually going to get this sort of efficiency. Well, no, the software world will never catch up with the many small core idea. The many small core idea has been around since the beginning of computers. Many people have come up with it, and time again, what chip do I admire more than any other chip? What's the best chip in the world? Everyone knows what's the best chip in the world. Who knows? Not the Pentium. Doritos, all right. Not the Brain. No, there's no 50 gigahertz. What's the best chip? Come on. The M1, there we go. Right? Like everyone knows it. The M1 blew everybody out of the water. Why is the M1 so good? Because it has one fast, powerful core. So what did the M1 do? The reason we switched back to multi-core is because of power dissipation. Yeah, I mean, you don't need to run things like... What is this? It's a very wide instruction machine. It's still a single core, but the instructions are very wide. The registers are very wide. The instructions are RISC. Registers wide. I mean, MatMul is a special case. I mean, all the things I'm doing. Oh, wait, we see the M2, yeah. How much faster the ASIC will be? I don't know. I mean, let's first implement it on the FPGA. Like, all right, so like realistically, what are the odds that I get to this kind of stuff? I have an idea that if I make this one work, I will make this work. Right? If I get to here, I'm likely to get to here in the business model. And you guys can help with this. If you guys want this to exist, you know, start helping. By the simulator, I mean that, you know, the cherry stuff that's in tinygrad. Programming multi-core is always going to suck. It's just fundamental. You'll learn so much making the first model that you'll redo the whole plan. I don't think so. I think the plan is pretty straightforward. Like, it's like build one big RISC core that can superscalar these operations. Programming multi-core sucks when your code has side effects. Well, okay, so you have multi-core. Okay, now tell me what you... let's go through why multi-core sucks, right? So, you have multi-core. Now, are you talking 10 cores or are you talking 1,000 cores? Right? Because the very different. 10 cores, it comes down to how coherent your cache is. Right? For 10 cores, you can have a coherent cache where they all effectively share a cache. And they have a unified memory model between them, and then this works. Right? But if you have 1,000 cores, well, what does your unified memory model look like? Do you have a cache for each core? And then if you have a cache for each core, well, what kind of things are these cores practically doing? Please check your... Oh, you submitted a PR to Twitch core? What do we got? Oh, value plus args. Cool. I was looking for how to do that. Wait, cool. And like this compiles? How do I... Is there any README? Test macros. Well, so what's building all these assembly things? Is there a makefile? Like how do I... Ideally, okay, here's what I would... There's a makefile. Here's what I would really like. Add GitHub Actions. Add GitHub Actions so this runs in the cloud. But yeah, looking good. Do we pass all the tests? Well, I'll merge it. Okay, firmware is make. Cool. Wait, so where did the files go that I made? Where's all the files? Oh, I have to do make add hex. Oh, no, I don't have that. I only have this one. I'm not sure how to get that one. Risk, yeah. This. Oh. No. I don't know how to get good. But yeah, if you could add some CI to this, it would be great. No, I don't want to run 64-bit. I don't understand why. I thought that my 64-bit RISC could build 32-bit, but maybe not, and maybe I have to fix that. But yeah. Anyway, I gotta go in like 5 minutes. I was actually looking for these tests. This is so much nicer than like I didn't actually find where they were. I just like how come I can build them if I go into risc-v tests and I type make? Like this works. What's it running? So it's running 64. Wait, is it actually just building them for 64? No, here it works. Here, you can use the 64-bit one if you just pass this stuff in. You can do CI, but you have to change from Verilog to system Verilog. Oh, does that stuff not work? I think system Verilog's okay as long as we can use the same simulator. And yeah, just switch the make file to 64s if you have them. No, it works, but it has some nice features. I don't know. Yeah, if it just works, I don't mind. Especially if you're only changing is the test bench. I mean, if you just change testbench.v to system Verilog, that should be, and like it still works with iVerilog. I don't care. Cool. But yeah, if you guys want to contribute to the tinygrad repo too, hopefully, you know, we got the tinygrad side of things, we got the Twitch core side of things. Yeah, Twitch core, man. Twitch core is gonna be an ASIC one day. Every line of Verilog that you write dreams of growing up and becoming an ASIC. You know what I'm saying? Well, yeah, and then we're going to have to start to add, all right, verification's probably a good thing to stand up, and then we have to add the vector instructions, then we have to add pipelining. Probably the first thing to do is get something running slow without any pipelining. Can you make a real logo for Cherry? Yeah, you can make a real logo for Cherry. Let's figure out, is this one, can we find a Creative Commons logo that like looks kind of like that? Yeah, if you want to make a real logo for Cherry. It's kind of a joke webpage. Cool. Thank you for watching the stream. Cherry Computer is real. Don't start a company. Just use Unicode Cherry. Oh, wow. Let's try that. Unicode Cherry. Oh, damn. Unicode can't be copyrighted. That's illegal. Okay. Wait. We're going to try something that's never been tried in the history of HTML. But now we have to close all the bigs. Oh, nice! You know the big tag? The big tag's my favorite HTML tag. By the way, how cool is that rendered? Wow, and if you look at it on mobile, it has a different logo. Thanks everyone for watching. Have a good night.